Alright. Let's go. It's a little late, but I'm trying to finish this before going to bed. Number of smooth descent periods of a stock medium. You're given inter-array prices representing the daily history of a stock, where prices I is the stock price in the active day. Sure. A smooth descent period of a stock consists of one or more contiguous days, such that the price on each day is lower than the price on the preceding day by exactly one. Okay, smooth descent. The first day of the period is exempted from this rule. Okay, obviously. Return the number of smooth descent periods. The number of them. So 3, 2 is 1. That's it. Oh, what the hell? Why would you consider a single day as a smooth descent? That's kind of I think I would define it as anything that is at least 2 days rather than 1 day, but because descent implies that there is some sort of difference between a preceding and a following value. But anyways, I guess, okay, so 3, 2, 3, 2, 2, 1, 3, 2, 1. Okay, all those are fine. So this seems like pretty straightforward. Sliding window. Pretty straightforward sliding window where the window resets if you don't see a actual difference of -1 from the preceding value, and the size of the window is going to be the current kind of longest descent period. And yeah, I guess I don't even need to track. I don't even need to consider a sliding window. I can just consider what is the length of the longest sequence of the length. So as I iterate over the array, the length of the longest sequence of descending values of 1. So 3 means that, well, 3 is just 1 by itself. 2 because it is 1 less than the previous, the streak is now 2. And 2 is also the number of periods that end with 2. So 2 by itself and 3, 2. So I add to that. 1 increases the streak to 3, and 3 is also the number of periods that end with 1. So 3, 2, 1, 2, 1, and 1. 4 resets the streak back to 1 because 4 is not 1 less than the previous value. So 4 is also, and that 1 value is the number of descending periods that end with 4. So I'll say here key point number, the streak of values, or smooth descending values, that end with the current value in the array, is equals the number of periods, number of smooth descent periods that end with that number, with that value. So I just need to, for each, as I iterate over the array, keep track of the streak, and then add basically that streak to the answer counter. So I'll say the current streak is 0. I'm going to actually do something like prices append an infinity, so that the first where I iterate over the values. Fuck. Actually, let me go ahead and say the previous value. previous value equals infinity. I don't know if this is any faster. If we're iterating over the values using a for each loop versus iterating over the indices using an indexed loop. I'll go with the for each and see how this works. So if for every value in the prices, if the value is one less than the previous value, then the current streak needs to be incremented. Actually, I think I should always increment the streak. So, that's fine. Actually, streak should be 0. Streak increments. Else streak goes back to 1. And then answer increments by the streak value, and previous is now the current value. Okay, so yeah, so this is using a for each loop rather than indices. I think that's slightly faster. Every value compared to the previous. If it's like 2 compared to 3, that should mean that it increases the streak of 1 to 2. If it's 3 compared to infinity, that should make the streak to 1. Answer increments. In theory, you can maybe even delete this because the first thing should always hit this portion. Answer maybe should be 1 initially, actually. Let me think about that. No, it's fine. Okay. I mean, in theory, I can get rid of this. I think. Because it's always going to set this thing first here. Oh man. Why is this so slow? Why so slow? Okay, so let me go and quickly check using indices. So let's say n equals prices length for every, and I still need a streak, right? I guess I can go starting with streak is 1, answer might be 1, and then use indices from 1 to n. For every index in range 1 to n, if the prices at this index is 1 less than the prices at index minus 1, then streak increments. Otherwise, streak resets. And then answer increments by the streak. Turn answer. I think that might work. Oh, shucks. What did I do wrong here? This gives me, it might not do the last streak, I think. 4, 1, Maybe I should start with 0 now. Prices at index is, oh my god, if this is just straight up equals 1 less than the previous one. Tricky. Let's see how this runs. Still not very fast. Oh, you know what? I could just do the answer incrementing when the values reset. When the values reset, then you can do some sort of quadratic quadratic calculation of the like n times n plus 1 over 2 or n times n minus 1 over 2 portions of the streak. So for instance, if there is a streak that is 3, 2, 1, and the 1 is like the last value where it actually smoothest ends, then implied within that there's a 3 streak, or plus 3 for everything that ends with 1, plus 2 that ends with 2, plus 1 that ends with 3. So there's implied like 3 plus 2 plus 1 calculation to the streaks. Arithmetic sum calculation. So instead of doing this multiple times, I skip this. Okay, so let me go ahead and when it resets right here, I think answer it needs to increment by the length of the streak times the length plus 1 over 2. Streak is 1, increases by 1, streak is 2, yeah. And then this thing goes away. And I think I do need one last one of these since it doesn't incorporate the last streak. So additional fence. Okay, Pythonic way is not having spaces between these expressions, portions of this expression. Okay. Okay. Alright, I'm gonna try running that. Oh, baby. I think maybe I should start with 0 at this point then. Does it start with 0? Is it off by 1? It is in fact off by 1. Why is it? Well, yeah, because, yeah, let me see. Well, if it's off by 1, I think that's right. Okay. Alright. Attempt number 3. Okay. Incrementally faster. Alright, so that's with the indices version. I'll go ahead and try with the for each version. So answer starts with 0 here. Entity for every value increment a streak. And then here answer increments by streak times streak plus 1 over 2. Streak increments. Remove this, and then one last one of these for the final streak. Shucks, cahoots. That's pretty far away from the answer. Whoops, I did a cut without the. Didn't intend to actually remove it from that spot. Just wanted to do a copy. Streak not defined. Okay, yeah. This does need to have initialization, unlike the previous attempt. Fudge. Actually, yeah, this should start with 0 because the first value needs to not add anything. Bingo bango. Cool, cool, cool. Alright, let's go ahead and clean this up. So the most optimized version will keep track of the streak of smooth descents, setting values while iterating over the values using a for each loop rather than an index loop, rather than using a variable that goes through the indices and gets the array at that index, just goes through each value. So could increase the answer counter by the okay, actually, so after checking and kind of checking, or after comparing current value to previous value, modify streak could increase the answer counter by the streak each loop, but better method is to only increase when streak resets. So you have like a 1 to 4, 1 to a non-zero value, assuming your previous value is 1, and yeah, 1's not smooth descending. And add the implied arithmetic sum of 1 plus 2 plus dot 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 to streak value to the counter answer to lessen the number of computations, right? Rather than adding 1 and then 2 and 3. That's 3 kind of executions of statements versus adding a single 3 times 4 over 2 calculation to this answer. Alright, time complexity, this could be O of n to iterate over the values in the array and keep track of streaks and answer. O of 1 to have variables, no extra space, no extra array needed.